Hey, this is Mr. Janes. In this video, we're going to be talking about completing the square. Make sure as you're watching this to pause the video when you need, try the practice problems before I do, and rewind if you miss something. Before we start, a quick warm-up. Try and solve these three quadratic equations. Pause the video here on a scrap piece of paper. These aren't in your notes, remember. It's just a warm-up. Try and solve these three out. Pause the video now. Alright, now that you've had a chance to try it, let's see how these shake out. So the first one looks like it might be difficult to factor, right? 4x squared plus 40x plus 25 equals 0. But actually it's not that bad if you recognize that this is actually a perfect square trinomial. Now remember, a perfect square trinomial is a trinomial that factors into the form ax plus b times itself. So we have two of the same exact factors. Now, how do we recognize a perfect square trinomial? Well, remember, ax plus b squared would be ax plus b times ax plus b. And if we FOIL that out and combine like terms, we will get a squared x squared plus 2abx plus b squared. So what I'm saying is that if you see a trinomial, like this one, where the leading coefficient is a square number, and the last number is a square number, then chances are you have a perfect square trinomial. So what you can do is recognize that, yeah, in fact this is. 4 is a square number, it's 2 squared. 25 is a square number, it's 5 squared. Okay. And 40 is 2 times 2 times 5, just like this, 2 times a times b. Which means that we can factor this into, what would that be? It would be 2x plus 5 squared equals 0. We're factoring it just like we see right up there. And of course, you could also solve this by splitting the middle term and factor by grouping. And if you do that, it's not a big deal. That's fine too. But this is a little bit of a shortcut. And we're going to need this shortcut later on in this video. But the nice thing about this is that to solve this equation, we can do it a little bit differently than we normally do. Notice how in this equation right here, there's only one x term. There's no x's and x squareds together. There's just this one x term. And we've talked about that if you only have that one x term, what you can go ahead and do is you don't need to factor. You can solve just by taking square roots. Here's what I mean. Take square root on both sides. Okay. Square root of 0 is 0. The square root and square cancel each other out. We're left with 2x plus 5 equals 0. And then we can subtract 5 from both sides. And we get 2x equals negative 5. And so we divide by 2, and x equals negative 5 halves, which also happens to be negative 2.5, if you want that as a decimal. And interestingly, there's only one solution to this problem, this equation. Normally with a quadratic we have two, but when you have a perfect square trinomial like we had up here, you only have one solution. Try and pause the video here if you haven't already, and try and do numbers 2 and 3. I'm not going to go over them, but the work will flash up in front of you, so please pause the video before you see the work. Pause now. Alright, here comes the work. So again, the second problem is a perfect square trinomial. We know this because the leading coefficient is 1, and the last, I guess the last number, the last term, is an 81. Both are perfect squares. Square root of 1 is 1, the square root of 81 is 9. And so this can factor into, I guess, 1x minus 9 squared. And so we just have 1x minus 9 squared equals 0. We take the square root of both sides. We add 9 to both sides, and we are left with one solution of x equals 9. Unfortunately, the last problem for the warm-up right here is not a perfect square trinomial. You'll notice that 6, definitely not a perfect square. 3, not a perfect square. And the middle is definitely not this 2 times a times b thing that we were talking about before. So this you'll have to do the old-fashioned way, factor by grouping, split that middle term, and you should get x equals 3 halves or x equals 1/3. If you want to look at that work, please pause the video here. Otherwise, we are moving on. On to completing the square and vertex form. Now, we've worked with the vertex form a little bit, but what is completing the square? Well, completing the square is a process that we can take an equation that is in, or a function that is in standard form, okay, and we can change that to vertex form. And the way that we're going to do that is by using perfect square trinomials. Remember, perfect square trinomials are the kinds of problems we just saw. Perfect square trinomials. And so vertex form, remember, from some of the explanations we've done, is a times x minus h squared plus k, and that is a function, so let's call it f of x, where h is the x value of the vertex, and k is the y value of the vertex. And a, well, some of you have called a our slope. I'm going to call a our horizontal, or sorry, our vertical stretch. How much the graph is stretched up so it's skinny or squashed so it's flat. So I'm going to call this our vertical, right, vertical stretch. All right, and that's what vertex form is. A times x minus h squared plus k, vertex form. And there it is right there in case you want to see it a little without the poor handwriting. Why is this so useful? Well, we know one reason why it's very useful, right? It's good for graphing, and we can easily find the vertex. But it's got one hidden reason why it is so important. Think back to the warm-up. These problems right here didn't require any factoring. They had pretty big numbers, like 4x squared plus 40x plus 25, but there was a process where we had no factoring. And if we could somehow get our quadratic equations to look more like they do in vertex form, then we wouldn't have to factor at all. We could solve an equation with no factoring, and that means it wouldn't matter what the numbers were or how big they were, we could still solve any quadratic equation. So the last one is to solve without factoring. All right, so our objective is going to be to change an equation from standard form into vertex form by using perfect square trinomials. So here's the idea behind completing the square. What we're going to need to do is start with an equation like this, or expression like this, x squared plus 8x plus blank. We're going to put something in that blank so that this whole expression becomes a perfect square trinomial. How's that going to work? Well, what we're going to do is take this number in the middle, divide it by 2, and square it. So 8 divided by 2 is 4, and 4 squared is 16. And we're going to drop a 16 right here. And the reason we're going to do that is because now when we look at this and think of, okay, what are two numbers that maybe multiply to 16 and add to 8, we can think 4 and 4, which means that this factors into x plus 4 and x plus 4, or x plus 4 squared. And if we can get something to look like that, we're going to have a much easier time solving a quadratic equation. No factoring at all. We can skip straight to that. Okay, well, what about this one? You know, if you can, pause the video here and try and figure out what you're going to have to add to each of these equations to make them a perfect square trinomial. Pause the video now. Right, so for the second one, let's see. We've got a 12 in the middle. So 12 divided by 2 is 6. 6 squared is 36. So now I can factor this into a minus 6 and a minus 6, or I could have skipped straight to a minus 6 squared. Another perfect square trinomial. This one's a little more difficult. So when we look at this, okay, there's a 2 out front. And so to make this a little easier, I'm going to factor the 2 out of this whole thing. Okay, so it'll be 2 x squared plus 6x plus blank. And so what do I have to add there? Well, 6 divided by 2 is 3. 3 squared is 9. So if I put a 9 there, that means I could factor this into 2. and x plus 3 and x plus 3, or 2x plus 3 squared. But that's not really what I was adding up at the top. If I added 9 here, that 9 is inside of parentheses with this 2 out front. So really, adding 9 in the second step is like adding 18 in my first step. And that's going to be an important fact when we do completing the score with some more complex problems. Lastly is this thing right here, m squared minus 9m plus blank. Now here's the problem. 9 is not an even number, so if I try and divide that by 2, I get 4.5. And then 4.5 squared, that's not fun. What's that going to be? That's going to be 20.25. So 20.25. I mean, I guess I can put that there. And if I were to factor that, I mean, following my rule, that means this would factor into m minus 4.5 squared. And in fact, that is how you would complete the score with that problem. We're not going to work on many problems like this, where you have to complete the square with an odd number. But it's important that you know that you still can do it, because later when we try and build a quadratic formula to do completing the square automatically for us, we're going to think about all sorts of numbers, including ones like 9 and decimals like 4.5. All right, let's actually try and solve by completing the square. Here's how it works. We have x squared minus 6x minus 72. Look at your first two terms, x squared minus 6x, and figure out what you'd have to add to those to have a perfect square trinomial. And we've done like one of these up above, where we had x squared plus 6x, and we realized we had to add 9. Remember, the middle term divided by 2 squared. So we're going to have to rewrite this as x squared minus 6x plus 9. But remember, if you add 9 to an expression, we can't just add 9 and leave the expression. We also have to subtract 9 to keep the equation balanced. And then here's our minus 72 equals 0. Now, take the first three terms. That now forms a perfect square trinomial. And so we can rewrite this as x minus 3 squared. Look at your last two terms. Those are kind of the leftovers. Combine those. Negative 9 and negative 72 make negative 81, and again equals 0. And now look what we've just done. We have created a situation where there is only one x term, which means we can solve this not by factoring, but by simply using inverse operations. So we could, I don't know, subtract 81 from, or sorry, add 81 to both sides. So we get 81. So 81 x minus 3 squared. We could take the square root of both sides. Okay, let's cancel each other out, and we're left with x minus 3 equals, well, we took a square root. So remember, that means this is plus or minus. So x minus 3 could equal negative 9, or x minus 3 could equal positive 9. And then to finish out, we add 3 to both sides of both of our equations. And we get x equals, let's see, either negative 6 or x could equal 12. And there you have it. We have solved an equation by completing the square. What I should do now is pause the video here, try and do the next problem, and the work is going to pop up all in front of you at once, so make sure you pause the video. Pause now. All right, here comes the work. Okay, so here's the work. Just to recap, remember, first I looked at the first two terms and figured out what I have to add to make it a perfect square trinomial, and that would be 36. But I can't just add 36 to an equation. I've got to add and subtract 36, because then if I were to combine those again, it would be 0, and I could get right back to my original equation. So I'm not unbalancing my equation at all. Then I took the first two terms, factored that to make x minus 6 squared. I took my last two terms to get negative 49. Then I just solved by inverse order of operations. Added 49 to both sides, took a square root, had to break up that equation into equaling 7 or negative 7, and then finished with x equals 13 or x equals 1. Alright, so let's take a look at the last two problems on this page, 16 and 17. And I'll do 16 now completely, and then we'll do the same thing as we did before with 17, where I'll do the work, it'll pop up on the screen, and we'll kind of review it quickly. 16 and 17 are a little bit different because unlike something like 14 where out in front there's, I guess, a 1, the leading coefficient of 16 is a 3, which makes a little bit of an issue for us, but not that big of an issue. Here's what we're going to do. We can still complete the square, but what we've got to do is factor that 3 out. Just like before, we only looked at the first 2 terms, okay, when we were completing the square. We will also look at only the first 2 terms when completing the square here as well. So we're going to factor out the 3 from only the first 2 terms and rewrite this as 3n squared minus 2n, and leave everything else. Minus 84 equals 0. And just like before, we're going to try and make this right here a perfect square trinomial. So what would we have to add to that to make a perfect square trinomial? Well, we've got n squared minus 2n. Let's see, 2 divided by 2 is 1. 1 squared is 1, which means that I'll have to rewrite this as 3n squared minus 2n plus 1. Now, I've just created a perfect square trinomial right here. But the issue is I just added 1, so I've got to subtract 1. But I added 1 inside these parentheses. So outside the parentheses, I've got to subtract not 1, but 3, because it was being multiplied by that 3. Just like above, when we did, say, this problem, and we added the 9 inside the parentheses, and we had to add the 18 outside the parentheses, same thing is going on here. To keep the equation balanced, if we add a 1 on the inside, that means we have to subtract a 3 on the outside. And of course, the rest of the equation just fills in right there. Just like before, we've got our perfect square trinomial that factors into n minus 1 squared. We've got the rest of that equation that we can combine, make negative 87. And then we bring down the equals 0, and we bring down the times 3. Okay? All right. And from here, again, we can just solve by using inverse order of operations. So I will, let's see, I will add 87 to both sides, plus 87, and get 3x minus 1 squared equals 87. I'll divide both sides by 3 and get x minus 1 squared equals 29. Okay? I'll take a square root, and this is a little interesting. The square root of 29 is a prime number, so I actually cannot take the square root of 29. So instead, I'm going to leave it like this. X minus 1 equals either positive square root of 29, or it equals negative square root of 29. And so I'm going to leave that as a radical for now, as a square root, I suppose, and keep going to subtract, or I should say add 1 to both sides of both equations, and x either equals 1 plus the square root of 29, or x equals 1 minus the square root of 29. Remember, I can't actually add these two things together because one's under square root, one's not. They're not like terms. I can't do that. So these are my answer. X equals 1 plus the square root of 29, or x equals 1 minus the square root of 29. And if you want to get fancy with that, you could write it as 1 plus or minus the square root of 29. Again, we're leaving it in here just because we can't reduce that square root. And in general, in Algebra 2, we're not going to try and make these into fractions or decimals. We're going to leave them as square roots. So, pause the video here and try and do 17. In a second, the work will flash up in front of you, and I'll kind of review the work just like I did for the last one. Again, pause the video now. All right, here comes the work. All right, and here is the work. The first thing I had to do was remember to move all of your terms to one side of the equation, so it equals 0. That was the first step. And then after that, we can complete the square. We factor that 7 out of only the first 2 terms, because remember, when we're completing the square, we only care about those first 2 terms. So we have 7 times parentheses n squared plus 2n, and that negative 21 hanging on the outside. We don't care about that. Negative 21, it's kind of like the leftover. And then we need to create a perfect square trinomial, and so we add 1 inside this parentheses. But remember, since we're adding 1, we've got to subtract 1, but subtracting 1 doesn't really work because inside those parentheses, so we subtract 7, because adding 1 in the parentheses is like adding 7, so we subtract 7 on the outside. In any case, this term in parentheses, this trinomial in parentheses, can be factored as a perfect square trinomial into n plus 1 squared. The left arm on the outside is negative 28, and from there we're just using inverse order of operations. We add 28 to both sides to get to this step. We divide both sides by 7 to get to this step. We take the square root of both sides, remembering that it's going to be plus or minus to get to this step. And then we subtract 1 from both sides to finish out the problem. And whoa, mistake. I made a mistake here. Subtracting 1 should leave us with, subtracting 1 from both sides should leave us with either n equals 1 or n equals negative 3. All right, well, at least I found my mistake at the very end. All right, this ends the video on completing the square. I'll scroll back up so you can see the other work. Hopefully you've gotten a good idea of how to do this. It's a pretty straightforward, although a little bit complicated operation. Next, please try and do the completing the square practice worksheet. The answers are online, so you can go ahead and check that as you're doing your work, see if you're getting it right. Please feel free to help each other out. If you see someone struggling in the class, please help them. And I'll also post other videos from Khan Academy in case you'd like to see some other examples of completing the square done out by maybe someone with a little bit of a different voice. Hope you have a great afternoon, and be sure to have that completing the square homework next class.